This time we don't have a prepared packet tracer file because we will be introducing a new device in this exercise and I want to show you how to connect it. Let me position this better. And we can open Packet Tracer and you'll find the Frame Relay Cloud in WAN emulation section. Pick the first cloud and drag it here. Then I'm going to add 2911 router. It's going to be named router 0. That's exactly what I need, but I'm not going to add another 3 routers. I'm going to copy this one. I need to add a module for serial connection into this router. I will use this HWIC-2T module. You could even add the covers here if you want to be super realistic. And then I'm going to power on the router and then I'm going to copy it. So I'm going to select it, Control C, Control V 3 times. Let's rename them to router 1. Whoops. Router 2 and router 3. Next, we need to connect them. I'm going to use this serial DCE cable and make sure to click on the cloud first because the cloud, since that is the service provider, is the one who should set our clock rate for these serial connections. So I'm going to click on the cloud first, choose serial 0, that's this S0 label here, and then I'm going to connect it to router 0 to serial 000. I'll do the same for the other 3 routers. So router 1 is going to be connected to serial 1. Serial 2 is going to go to router 2. And on each router, I'm going to use serial 000. I'm going to also add labels to make things easier for us. Now that we're done with this, let's go to our first task, which says we should configure the Frame Relay Cloud according to the logical diagram below. What we're supposed to do here is we're supposed to emulate what we have on this drawing here in here. And the way to do that is, of course, this cloud is actually a device. It's just emulating the cloud. When you go to the config tab here, you will see all these interfaces that we used to connect our routers to. What we will do now is we will tell each of these interfaces which DLCIs they will have connected to them. So on serial 0, that's S0 here, we will have 2 DLCIs because we have 2 links connecting here, right? So we will have 101 and 201. Let's add those. I'm going to say 101 and then I can put a name here. And this name is very useful, so don't skip it. I'm going to show you later why it's useful. What I'm going to say here is I'm going to put router 0 dash router 3 here. And what that does is it shows me what this DLCI is actually doing. So this DLCI represents a link between router 0 and router 3. Let's look at it that way, okay? Next, we have DLCI 201 here. So we're looking at this interface right here. And that DLCI represents the link that connects router 0 and router 2. We're going to add that. Moving on to serial 1. Here we have a router 1 connected, and we only have one DLCI. So that one DLCI is 401, and it represents the link between router 1 and router 3, right? If we look at this link here, it connects to router 1 and router 3. Add. Serial 2 is right here. We have two links here, 202, and that connects router 2 with router 0. And then we have 301, and that connects router 2 with router 3. If we go to serial 3, we're supposed to add 3 different links here. Let's start from 102. This one connects router 3 with router 0. And then 302, which connects router 3 with router 2. And then 402, which connects router 3 with router 1. Now, these were just individual serial interfaces. Next step is connecting those. So here we will have a list of 4 different links, which is exactly the amount of links we have in our cloud. So let's start. Let's start from this link between a router 0 and a router 3. We need to pick serial 0 on one side and serial 3 on the other side. Serial 0, serial 3. On one side, we're going to pick router 0, router 3, and on the other side, we're going to pick router 3, router 0. Add that link. Next, let's connect router 0 and router 2. Again, we need serial 0, but this time we're going to say router 0 dash router 2 on this side, and on this side we need to switch to serial 2 and choose router 2 dash router 0 because that's the link we're going for. Now let's go to router 2 to router 3. We need to connect serial 2, which connects router 2 and router 3. And on the other side, we have serial 3, which connects router 3 and the router 2. And one last link is this link between a router 1 and a router 3. We need to go to serial 1, and we only have one option here. And on serial 3, we need to make sure that we pick router 3 to router 1. That is how you configure this Frame Relay Cloud emulation in Packet Tracer. If anything is unclear, I have explained these steps in this exercise guide, so you can go back to this and do it again on your own if maybe I went too fast, and you can catch up. Our next task is rather simple. We are required to set up host names on all 4 routers. So we're going to say no here. Enable configure terminal hostname router 0. Moving on to router 1. And now the real deal. Task number 3, configure frame relay protocol according to the logical diagram. Logical diagram is right here, but let's look at the commands first. As already mentioned, frame relay is a protocol. When your packets traverse the frame relay cloud, they get encapsulated. And this is exactly what this command does. It informs this interface right here that it will be getting packets encapsulated according to the frame relay protocol. And what we need to do on the physical interface, let's call it that. So on the serial interfaces, on the routers, we need to tell the interface, expect frame relay here, and no shutdown, meaning we need to switch on the interface. And that's it. And we will do this on all 4 routers on these serial 000 interfaces. Next thing we want to do, let me bring this logical diagram here. So next thing we want to do is we want to define the DLCI and the IP address on the sub interface. So this is going to be a frame relay sub interface. In this exercise, we're doing point-to-point. In the next lesson, we'll do multi-point, but for now, bear with me. So now we're going to do point-to-point. This means that each of these links has its own subnet, and as you could see in the presentation, logically what that would look like is as if those routers were directly connected to each other. Okay, to create the subinterface, we will use these commands. We will use, in case of router 0, creating this link right here, we will say interface serial 000.101 and then point to point. Now, 101 is the DLCI number here, but you don't actually have to use the DLCI number. You can use any number. We use the DLCI number to make the configuration a bit more common sense, and also when you are looking back at the configuration, it's more intuitive and you can kind of guess what this is. Of course, in the next command, you should, or you don't really have to do this first, you can do it after the IP address. I'm not indicating the importance of order here, but anyway, at some point you should define the DLCI number, and obviously it's important to use that exact number that you were given by your provider. The next thing you want to do is you want to set up the IP address just as you would in a point-to-point link, in a direct point-to-point link, I want to say, between 2 routers. And then on the other side, on router 3, you want to do the exact same thing, only this time you will use the DLCI number given for this end of the link. By the way, these numbers, they can be the same, so you can have one link and the same DLCI number on both ends of that link. All right, let's get into our configuration. I'm going to look at this logical diagram here while I do it. Let's start with router 0. So remember, first, we want to configure the physical serial interfaces. Interface serial 000, encapsulation frame relay, no shutdown. We need to do the same thing on the other 3 routers. So interface serial 000, encapsulation frame relay, no shutdown. Next, configuring subinterfaces, and I'm going to do it link by link. I usually do it router by router, but I feel like you'll need some practice in order to feel comfortable enough to do that. So I'm just going to do it link by link. Let's start from this link. We're going to create a subinterface on router 0, interface serial 000.101 point to point. Then we want to say frame relay interface DLCI 101, and then we want to set the IP address. IP address 10.101.255.255.255.252, and then exit. Moving on to router 3. Interface serial 000.102 point to point, frame relay interface DLCI 102, IP address 10.102.255.255.252, exit. At this point, this link between router 0 and router 3 is already established. This means that we should be able to ping in between them. So I'm going to try that from here. I'm going to say do ping 10.101, and it works. Let's move on to this link between router 0 and router 2. So going back to router 0, and with this we'll be done with configuring router 0 for frame relay at least. We're going to create a different subinterface, so interface serial 000.201 this time, and then point to point. And then we're going to say frame relay interface DLCI 201, IP address 10.201.255.255.255.252, exit. Moving on to router 2, we need to create the subinterface serial 000.202 point to point, frame relay interface DLCI 202, IP address 10.202, mask, and exit. Let's move on to the next link. That would be this 10.300 link. We need to create an interface for that. Interface serial 000.301 point to point, frame relay interface DLCI 301, IP address 10.301.255.255.255.252, and then moving on to router 3. Creating our second subinterface here, serial 000.302 point to point, frame relay interface DLCI 302. So I'm using a really short command for this. Don't get confused. It's short for frame relay interface DLCI 302, IP address 10.302, and then the mask, and that's that. Let's now configure the link between a router 1 and a router 3. We need to configure the subinterface here, interface serial 000.401 point to point, frame relay interface DLCI 401, IP address 10.401.255.255.255.252, and then on a router 3 we'll have interface serial 000.201 402 point-to-point frame relay interface DLCI 402 IP address 10402/30. All good. Now let's test the connectivity. I don't want to do that. Okay, we're going to try the links where we have the point-to-point connection, so between router 0 and router 2, between router 0 and router 3. We also have a direct connection between router 1 and router 3, and the fourth link between a router 2 and router 3. And all of those were successful, but if we try to ping between a router 0 and router 1, that's going to fail. And another thing that's going to fail is the ping between router 1 and router 2. Why is that failing? Well, that's failing because we simply don't have the link between those routers. The way to fix that would be 1, static routing, or 2, a dynamic routing protocol. And in this case, we're going to use RIP, and of course, RIP version 2. So let's configure that. I'm going to go to router 0 and I'm going to look at the logical diagram here. Router RIP version 2, no auto summary. And then we need to list all the networks that are directly connected to this router. Those networks are 10.1.0.0 and 10.2.0.0. So network 10.1.0.0 and network 10.2.0.0. We're gonna do the same thing with all other routers. And that's it. Now, router 1, for example, should be able to see all of these remote networks, such as 10.2.0.0, 10.1.0.0, 10.3.0.0. So I'm going to say do show IP route. And yep, we can see all of the networks from this exercise. So now let's test that. I'm just going to refresh these pings. And since they're successful, we can consider our exercise successful. Of course, you will find all of the necessary commands in your exercise guide. In our next lesson, we will deal with multi-point frame relay. See you there.